Hello, geometry students. So today we're continuing where we left off in yesterday's notes. And yesterday we kind of had to cut the notes off early. So the problem that we finished with was example 4. And today we're moving on to example 5. So make sure you know where that is in your packet. So if you need to, take a moment and pause this video. We should be done with this one, and now we're picking up on example 5. Then we'll go into the 2-6 day 2 note page. So yesterday we started talking about proofs, and remember, proofs are when we justify each step of our problem-solving process. So it does get a little tough because we break down each teeny tiny minute detail, but this is the backbone of mathematics, and that's why it's such an important skill to have, because then we truly know that we understand what's going on in the problem. So let's get into this problem. It says, given the measure of angle HLJ is equal to 2x plus 40, and the measure of angle JLI is equal to 5x. Prove that the measure of angle KLI is 80 degrees. Okay, so I am going to draw in my image this time a little bit of the stuff that I know. So it says HLJ is 2x plus 40. So I'm going to label that just so I have a good idea. And then it says JLI, which is this angle right here, is 5x. And we're trying to prove that KLI is 80 degrees. So this is what we're trying to prove. I'll put a little box around it so we know that it's not quite there yet. It's not part of our given or anything. It's what we're trying to get to. Okay, so now that I have my image a little bit more organized, let's go ahead and write in our first statement, which is the given. So I am going to say measure of angle HLJ is equal to 2x plus 40. And the measure of angle JLI is equal to 5x. And that is what I was given. After that, for the second step, I should say, I want to pull from something that I know. So notice how in this image, these two angles, this angle and this angle, form a straight line. It forms the line HI. So I can then say, oh, hey, this angle plus this angle adds up to 180 degrees because they're a linear pair. So that's what I'm going to say. I'm going to say measure of angle HLJ plus measure of angle JLI is equal to 180 degrees. And the reason I know that is because of the definition of linear pair. A linear pair are two angles that are right beside each other that form a straight line. Now pulling from this information, I can go a step further with this equation. Remember, HLJ is actually equal to 2x plus 40. So I can take this 2x plus 40 and stick it in for HLJ. So that's what I'm going to do. I'm going to substitute in different values. So now I have 2x plus 40 plus, and then JLI, it says JLI is equal to 5x. So instead of writing JLI, I'm going to write 5x because these two things are interchangeable. They are equal to each other. They have the same value. So that means I can substitute one in for the other. So I have plus 5x is equal to 180 degrees. What I did there was substitution. Okay, now I can start solving this and see what it gets me. So step 4, it's going to be 7x plus 40 is equal to 180 degrees. Well, that was combining like terms. For step 5, I'm just trying to solve for x right now, so I'm going to subtract 40 from both sides. So I have 7x is equal to 140 degrees. and that was the subtraction property of equality. Then step 6, I'm going to divide both sides by 7, and I am going to get x is equal to 20 degrees. So for step 6, we did the division property of equality. Okay, we got to x equals 20, but the thing is, that's not what we were asked to prove. So now we have to ask ourselves, how can I use this 20 degrees to kind of propel me towards the answer? How can this get me closer to the measure of angle KLI being 80 degrees? Well, what I want you to notice first is that JLH and KLI are vertical angles. They are vertical angles. So I'm going to mark that in our image with a highlighter. And what's so important about that is vertical angles are congruent. So if we can show that HLJ is 80 degrees, then we can show that KLI is 80 degrees as well. So what we're going to do, we're going to take this 20 and we're going to substitute it in for the x. So let's do that now. So 7. So let's see here. The measure of angle HLJ is equal to 2 times 20 plus 40, which that simplified down is going to get us 80 degrees because 2 times 20 is 40, and then 40 plus 40 is 80 degrees. So what I did here was I took this 20 and I substituted it in to this expression that I was told in the given. So I don't have to rewrite that I was given that. I was already told it up here. So I can use this information in another step down here, which is what I did. And I took this x equals 20 and substituted it in for the x right here. When I simplified it, I got 80 degrees. And so that was substitution. We substituted a value in, so substitution. Okay. Then we also know that angle HLJ and KLI are congruent to each other because they are vertical angles. So I am going to say angle HLJ is congruent to angle KLI. And the reason that is because they are vertical angles. So I'm going to say definition of vertical angles. Actually, no, I'm going to say vertical angles are congruent. That's what I'm going to say instead. This is a better way to put it. Vertical angles are congruent. Now notice I have a congruent symbol right here, but I'm going to need to get it to an equal sign. So we're going to have to use our definition of congruence again to get that over to an equal sign. So now I have measure of angle, let's see here, HLJ is equal to measure of angle KLI. That was definition of congruence. And finally, I can say, oh, hey, the measure of angle HLJ is 80 degrees. So I'm going to say 80 degrees is equal to measure of angle KLI. That was substitution again. And we have an extra step this time because I didn't write this in the convenient order, unfortunately. So we're going to have to flip these two around so I can get it measure of angle KLI equals 80. So I'm now going to say measure of angle KLI is equal to 80 degrees. And that is our symmetric property. Remember the symmetric property, we can flip an equation backwards. And now we have our last statement matching our proof. So that was a pretty lengthy proof, which is why I kept it for the second day of notes. Let's now switch gears just slightly. We're actually moving into the next day of notes now. And you'll be relieved that this next proof is not nearly as long as that one, okay? So some of them are long and some of them are short. Alrighty, for this next set of notes, we are in section 2-6, day 2. And we're still doing proofs and reasoning, but we're just practicing a little bit more because it's a different way to kind of get your mind thinking. So we do need to practice and really, improve our skills with this. So what I want you to recall, a proof breaks down a problem step by step, and it gives a reason for each step of the process. You cannot say it's that way just because I think so. You have to have a very legitimate reason to back up your work. So also, reasons are typically definitions, theorems, postulates, and properties. So our reasons are on our right-hand side of the column, and those are going to be our definitions, our theorems, things like that. Our statements, which is on the left-hand side, are the actual steps you take to get to the end of your problem. Okay, so let's look at example 1 now because this is a new page of notes and a new section of notes as well. So it says measure of angle ABE is congruent to measure of angle DBC. So I'm going to do my best to mark that for you. Let's see here. I will mark it like this. This angle and that angle. Okay, so from A to B to E, the top two angles and the bottom two angles, those are congruent to each other. We're trying to prove ABD, or this guy up here, is congruent to EBC, or this guy down here. Okay, so now that we have a better idea of what we're doing, let's go in with our first step, which is going to be measure of angle ABE is equal to the measure of angle DBC. And that was given to us. Next, looking at step 2. We have two small angles being combined to get the total angle right here. So remember, that's our angle addition postulate. So let's go ahead and use that. Because remember, the angle addition postulate is oftentimes something that we use to create an equation. So now we have measure of angle ABD plus the measure of angle DBE is equal to the measure of angle ABE. So I said this top half plus this bottom half equals the total angle. But I can do the same thing, so I'm going to say and. Now I'm going to say that EBC and DBE are also going to add up to the bottom half. So I'm using the angle addition postulate twice. So I'm going to say the measure of angle EBC plus the measure of angle DBE is equal to the measure of angle DBC. So remember, the top two angles are adding up to the top two, and the bottom two angles are adding up to the bottom two, and there's an overlap right here in the middle. Alrighty. What did we do to support, or what can we use to support that step, I should say? That is our angle addition postulate. Moving on to step 3. What I want you to notice is we were told ABE and DBC, their measures are the same. And we have expressions that can be used to represent those angles. So I have measure of angle ABE is all of this stuff, and the measure of angle DBC is all of this stuff. So I'm going to use, I'll try to kind of color code it a little bit for you. This part represents measure of angle ABE, and right here is ABE. So I can take this and replace it right here. But I also have, let me find a different color pen, maybe. I have a black pen at least. This part and this part are going to replace this guy right here. So my new equation is going to be the measure of angle ABD plus the measure of angle DBE is going to equal measure of angle EBC plus measure of angle DBE. All we did was substitution. It's just a little bit confusing, I think, because you're not used to substituting in something bigger for, or some, like a longer expression for a short expression, but you are allowed to do that. Okay, so now we have this expression. We're down to our very last step. Can you believe it already? What I want you to notice is the measure of angle DBE is on both sides. It's right here, and it's right here. We are allowed to subtract that value from the left and right sides of our equation, because remember, what you do to one side of the equation, you must do to the other. As long as you do the same thing, it is a legal math operation. So I'm going to subtract this from both sides, making them disappear, and now I have the measure of angle ABD is equal to the measure of angle EBC, and that was the subtraction property of equality. And we're done there because my final statement matches my proof statement. Okay, so that one was a little bit easier than that last one that we did. We have one more problem to do, and it's going to be a little lengthy as well, but I don't think it's going to be too bad. So here we're told that M is the midpoint of RQ, and M is the midpoint of SP, and SP is congruent to RQ. Okay, so I'm going to go ahead and mark some stuff that I know. So because M is the midpoint of this guy, I'm going to mark these two things congruent. And because M is the midpoint of these guys, I'm also going to mark these guys congruent as well. I also know that the entire length of SP is congruent to the entire length of RQ. What we're trying to prove is MQ being congruent to MP. So I'm going to kind of color over those just a little bit so we kind of keep our eye on the prize, so to speak. So we know what segments we really want to focus on. Okay, so let's just start with what we know. That's a great place to start. If you don't know what you're doing in a problem, just write down something that you know. Everybody knows the given, so let's write that down. M is the midpoint of RQ, and M is the midpoint of SP, and SP is congruent to RQ. What do we know about that, or why do we know it? It's given to us. Moving on to step 2. we are given a very valuable clue. This says midpoint and midpoint. So I'm going to go ahead and state that definition, saying that RM is congruent to MQ and SM is congruent to MP because of the definition of midpoint. So I'm going to have RM is congruent to MQ and SM is congruent to MP, and that is the definition of midpoint. Okay. Now, something that is a little bit annoying in this proof, we're going to have to turn this congruency symbol into an equal sign, then turn it back into a congruency symbol. So we've been working on that, where we turn a congruency symbol into an equal sign, and it's going to be the definition of congruency. So let's go ahead and do that. Let's turn this into RM is equal to MQ and SM is equal to MP. That is the definition of congruence. Now notice the difference between these two steps. This step has the congruency symbol and it has the segment symbol on top of the letters. In the step below it, I have equal signs and there's no segment symbol on top of the letters. That's because this means length of SM is equal to length of MP. And I needed to get it like this because I want to use my segment addition postulate. And I can't use my segment addition postulate with congruency. I have to have an equal sign. Okay, so now that I have these segments, I'm going to set up my segment addition postulate, and I'm going to say R to M plus M to Q is going to equal RQ, and then for the other segment as well. So RM plus MQ is going to equal RQ, and SM plus MP is going to equal SP. That is our segment addition postulate. Now, this next step is very similar to what we did in the previous example where we said, oh, hey, RQ is RM plus MQ. And then I'm also going to say that SM plus MQ is equal to SP, so I can set these things equal to each other because they're congruent to each other. So I'm actually going to put that up here before I forget it. So, and SP is equal to RQ. Let's do that, just so we cover our tracks. So I can use the substitution property here, and I'm going to replace this RQ with RM and MQ and this SP with SM and MP from this equation up here. So I'm now at RM plus MQ is equal to SM plus MP. That was the substitution property. We're going to do the substitution property again because what we can do, we can replace this RM with MQ because it's equal to each other up here. And I can also replace this this SM with MP because they're equal to each other based off of step 3 up here as well. So now I'm going to have MQ plus MQ is equal to MP plus MP. That was the substitution property again. Okay. Now I can combine like terms on both sides. So I have 2MQ is equal to 2MP. Well, that was just combining like terms. Then for step 8, I can divide both sides by 2. So I'm going to get MQ is equal to MP. Well, that's just the division property of equality. And for my very last step, I ran out of space, just barely. I'm going to turn my equal sign back into the congruency symbol. And that is just definition of congruence. And finally, my MQ is congruent to MP, matches what my proof statement is. So this one was a little tricky because we had to substitute a number of times and we had to double our segment and then divide it by 2. So we'll do more practice with tougher problems like this. But until then, just make sure that you're practicing your reasons and your definitions, and that'll definitely help give you the foundation for being good at proofs. See you tomorrow. Bye.